Positively perfect problem solving presents applied arithmetic. In the last learning target for this unit, we're going to talk about finding areas and perimeters of squares and rectangles. I wanted to make sure to set you up with this, with our practice of fractions and decimals, because some of our problems in this learning target deal with that. So that's kind of where we're headed, is to being able to use this math we've talked about. So an area and perimeters are really important. So first of all, let's remember the difference between area and perimeter. So area is the amount of space inside an object. We typically work with two-dimensional objects, not 3D shapes. So it's technically the space inside those two-dimensional objects. So if we take a look over here on the right at these three shapes, when I think of something inside, it's kind of nice to break it up into little units or squares. So you can see here that the area of this shape right here, this top horizontal thing, has 1 unit, 2, 3, 4, 5, 6, 7, 8, 9. So it has an area of 9 units. Similarly, so does this one. Area of 1, 2, 3, 4, 5, 6, 7, 8, 9. Also an area of 9. And this final shape also has an area of 9. Even though it's not a square or rectangle, which is typically what we're working with, I still underlined three total cubes. So all three of these shapes have an area of 9. Okay, now you're all typically used to just thinking area as length times width, which you can still do. You know, this side is a measure of 1, this side's a measure of 9. 9 times 1 is 9. This side has a measure of 3 because you've got 3 sides. This other side is a measure of 3. And 3 times 3 is still 9. So counting the insides of the units is the same as area, and so is the multiplying length times width as well. Okay, so two different kind of ways to think about area. Perimeter is different, and a lot of us get perimeter and area confused. Perimeter is the distance around an object. Okay. So I'm going to look at this rectangle over here. One side length is 7, one side length is 3, the other is 7, the other is 3. So when I want to find the perimeter, I would have to add all these up, right? 7 plus 7 plus 3 plus 3. It's very similar, and I like to think of it like a yard. Like when you have a house and you've got a yard in the backyard. I've got a purple yard, so here's my yard. And I've got some grass, and I've maybe got like a tree here, whatever. I have a porch. So there's my yard, right? But then around your yard, to give you privacy, you've got your fence. So here's my fence surrounding my yard. Fence, 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 fence. Now notice that my fence is not included inside my yard. It's just what's around it. So if I go tell someone I need to tear my fence down and rebuild my fence, they're only going to measure that length, and that length, the measure outside. But if I go and want to plant all new grass inside my yard, my grass is dying and I've got to put all new grass in here, I'm then calculating the area inside my yard, which is usually it's a much bigger number because you're dealing with a much larger space. So area is the space inside the object, perimeter is the distance around an object. Okay. I like to think of it as a yard. It really helps me keep track. So let's practice finding perimeters of squares and rectangles. So let's talk really quickly about what a square and a rectangle is. Okay, it's been a while, probably. So a square. What makes something a square? Something is a square if it has 4 sides and all sides are equal. That is what makes something a square. Okay. So this guy right here, this 27, 27, since this is 27 and this is 27, you can make the assumption then that it's a square, and this side must also be 27 and this side must also be 27. In this learning target, the hard part for you guys is going to be making those assumptions, using what you know to assume, well, if I know this side is that, then the other side has to be that as well. So all of these sides are 27 kilometers. Okay, a rectangle, okay, on the other hand, is similar to a square. It has 4 sides, but they're not all equal. But the rule is that opposite sides are equal. And I'll show you what I'm, oops, my pen did a weird thing. Opposite sides are equal. Let me write that correctly. So that's what that means. So notice that this is 1/3 and this is 2/9. Those aren't equal, so this isn't a square. However, since it's got these right angles here, it's definitely a square-ish shape. Okay, then I know that this one side right here, because this is 2/9, that means that this side has to be 2/9. And because this one side is 1/3, this side has to be 1/3. So I'm making that assumption looking at a rectangle. Opposite sides are the same length. So we're going to start with finding area of squares and rectangles. And I made a typo up here. This should say, not on your paper, it says area. So your paper is fine. It's my video that's wrong. So now it should match your paper. Okay, so we're going to go ahead and find area of these shapes. Now to find area of a square, okay, the area of a square is, and of a rectangle, sorry, area of a square and a rectangle is length, let me write this a little nicer here. Okay, the area of a rectangle and a square, okay, good now, is length times width. I like to abbreviate that, and most mathematicians do, the L and the W. L always looks like a curvy L, because otherwise if I write this, that looks like a 1. So whenever you make a little L variable, you always make it a cursive L, just so we don't get confused. Okay, so area of a square rectangle is length times width. Basically what that means is that you're multiplying one side by another side. Okay, so it's like a side times another side. So for this problem over here, I want to find the area of this. I'm going to do 27 times 27. Okay, and I have no idea what that is at the top of my head. So I'm going to go ahead and use my trusty calculator. Okay, and I'm going to get 27. Oops, let me turn it on first. Come on. Okay, 27 times 27. Gives me 729. So the area is 729. Now, do you notice how there's units here? Kilometer, kilometer. I will take off half points for not putting units. And when we do area, we always write the unit, and then we put a little 2 up here. That 2 means squared, because we're squaring it. We're finding an area, so we're multiplying it by itself, which is squaring. So that's why we always say kilometers or meters or whatever squared, okay? Area of the perimeter is the same thing. Area of the perimeter is going to be, but this one's just fractions, so it's just a little scarier. Don't be scared. It's okay. I taught you how to do that. So the area here is going to be 1/3 times 2/9. And remember, I taught you guys this in the calculator. Parentheses 1 divided by 3, parentheses, times 2 divided by, oops, I missed my 2. 2 divided by 9, parentheses. Turn that into a fraction, hit enter, enter, and I get 2/27. Again, do not forget to put the unit. In this case, it's meters. So meters squared. Okay. The next thing in this learning target is talking about perimeter. So perimeter of squares and rectangles are done the same way. The difference between perimeter and area is while area is a multiplying problem, perimeter, you're just adding up the sides around it. If I were building a fence, remember my green fence that I had in my yard? If I'm building a fence, I need to decide and measure how much each side is so I can buy enough fence. I don't need this stuff in here. I don't need that. I just need what's around it. So it's an adding type of problem. Perimeter is an adding. So the way that formula kind of looks like is I've got perimeter Oh, let me make that a little nicer. Perimeter is really, and again, I'm going to use my fancy L, length plus width plus width. Okay, that's one way you can write this out. The other way you can think about this is when you have two of something, you can, if I have something like L plus L, that's equal to 2 times L, because I've got two of them. So another way that we can write this formula is we can say P equals 2L plus 2W. Now, you don't need to use this formula. I'm just kind of giving you a way if some of you like the formulas. If you want to just take these 27s, label 27 on all four sides, because it's a square, right? So because it's a square, all four sides are the same. And you want to write this out, 27 plus 27 plus 27 plus 27. If you want to do that, cool. It's going to be a little more work for you. That's okay. You'll just press more buttons on the calculator. You'll do 27 plus 27 plus 27 plus 27. It's just more on the calculator, in my mind. Okay, and you get 108. So now you know that the perimeter is 108, and don't forget the kilometers. You don't need the squared because we're not actually multiplying anything. You only put a squared for multiplying. Now, if you're someone who does not want to put that many numbers in a calculator, you could recognize that since there are 4 27s here, you could turn that into 4, I won't do parentheses because parentheses I think freak you out, 4 times 27. And you'll get the same result. You're just saving yourself some step. 4 times 27. You know, it's important to realize that adding and multiplying relationship. If you're adding up a bunch of stuff, you're really multiplying that thing that many times. So that connection between adding and multiplying is valuable. It saves you time. And it's going to lead into more things that need that little trick. So instead of just adding all that up all the time for squares, try to just multiply that by 4. You'll get the same answer, and that's okay. The other one is a rectangle. And rectangle perimeters are a little bit different because you're not just dealing with one value. So for this particular rectangle, and we talked about this before, it's the same rectangle. I didn't change the numbers. So we already talked about how this must be 2/9 and this must be 1/3. Again, meters and meters. So now if we're doing perimeter, I'm going to now add all these up. So I'm going to have 2/9 plus 2/9 plus 1/3 plus 1/3. Now, the calculator will do this. It's going to take a lot of button pressing. I'm going to show you. You got to put parentheses around each fraction. 2 divided by 9 parentheses plus 2 divided by 9 parentheses plus 1 divided by 3 parentheses plus 1 divided by 3 close parentheses. Oops, I didn't put the 3 in there. You'll hit enter. You'll turn it into a fraction, and you're going to get 10/9. Okay, it's a lot of button pressing. I mean, I'd rather do the calculator than by hand, but it's still a lot. So you end up getting that the perimeter is 10/9 meter. Now, if you want to save yourself some time, again, you can do this trick where, see how I have a group of let me use blue. See how I have this little group right here? I can turn that into 2 times 2/9. And I've got this little group here. I can do that 2 times 1/3. It doesn't save me that much button pressing, but it still will work. Notice 2 and then parentheses 2 divided by 9, close the parentheses, plus 2 and then put your fraction in the other one in here. And notice how it looks exactly like my paper. You should get the same answer, and then you see that I do. So I'm trying to teach you guys these shortcuts. They help you. It's good to know these relationships, so you still get the same answer either way. Okay? So that's area and perimeter. Cool. The other thing we have to be able to do with area and perimeter, and this is some logical reasoning, is finding missing pieces of squares and rectangles. Okay, using what we know about area and perimeter. So when I see this problem right here, it says find the missing side length when the perimeter is 102 feet. So I only have one, it's a clue. You're kind of like being a detective here. What do you know in this problem? Well, you know that one side is 43. Well, if I know that one side of a rectangle is 43, then I automatically know that this is 43. So I've got a second piece of information, okay? Now, how do I figure out these other two sides? Well, I know that the total perimeter is 102 feet, okay? 43 and 43, if I add those up, that gives me 86. So 86 feet of my 102 total are coming from this side and are coming from that side. So if I then subtract that 86 from my perimeter, let's do that in our calculator here, 102 minus 86, that's going to give me 16, okay? So that means when I get that 16, it does not mean that both these two sides are 16. Originally, it might be what you think. Oh, I subtracted these two together and what's left over is 16, so that means that I've got 16 on either side. But remember, the 16 here, this 16 is what you get when you add these two together. So if I add these two numbers together to get 16, logically, this must be 8 and this must be 8 because they have to be the same. Okay, now I went through that really quickly and I know that I did. So this might be something you want to rewind and watch again as my process. Okay, I'm going to check my work because I may have made a mistake. And to check your work, all you do is you add it all up. 43 plus 43 plus 8 plus 8. That's going to give me 86 plus 16. And when I put 86 plus 16 in my calculator, I get that 102 as my perimeter, okay? So I know my final answer is 8 feet. That's the missing side length. There is another way to do it. I haven't taught you this yet, and if you guys want to impress me and show me some cool algebra, you can. I'll show you algebraically how you can do this easier. But again, I don't care which way you do it, but I am going to show you the algebraic method just so you have it. Algebraically, your formula is P equals the 2L plus the 2W, okay? So I know my perimeter. They tell me it's 102, so I know perimeter is 102. I keep this 2 here. That doesn't change. And I know that my length is 43. I'm just replacing all of these letters with numbers that I know. Plus 2 times whatever the width is. I don't know what the width is. I mean, I do. I know it's 8, but I don't know in the original problem. Now you just can solve this if you know how to solve. Oh, that's an equal sign. 102 equals 86 plus 2W. Solve like an equation. I don't expect any of you to do this. I'm showing it to you so you know. But I do not require this. This is a lot. So 82 minus 86 is 16. You have the 2W left over. Divide by 2, and that is a 3 that I just wrote. And I still get 8 in the end. So I get 8 this way. I also get 8 the other way. So either way, I don't care right now. I might care in the future, but right now, if you don't want to use any formulas, you just want to logically plan it out, go for it. I don't care. I just care that it's correct and you can defend your reasoning, okay? The other reasoning skill we're going to work with is with area. So that's reasoning with perimeter. Reasoning with area is way easier. It is not as scary as perimeter. Perimeter reasoning is a little trickier. But reasoning with area is much simpler. So here, find the missing side length when the area is 608 square units. So really, you're asking yourself the question, because area is multiplying, right? You're saying, look, I have area is length times width. I know that my area is 608. I know that my width is 16. I don't know my length. So you're asking yourself, what has to be here that if I multiply by 16, I get 608? So really, you just do the opposite and you divide it to find that missing length. So that's just a simple division problem. You just have to ask yourself, what times 16 gives me 608? So divide it and find out. 608 divided by 16 gives me 38. Now test this, okay? If I truly think that this is 38, how would I test it? Well, I'd take my 38, I'd take my 16, and I'm going to check to see if it's correct by multiplying them and see if I get 608. So 16 times 38 is 608. So I know that my answer is going to be 38 square units. Now, units just means lines, like a unit of something. And we're going to talk about that in a second with the next example. Okay, so there's no, you could write 38 units on here if you wanted to. Okay, it's a math way we describe a measurement we don't know. Okay. One last example, and this is going to come into play. You have a project for this unit, and it's creating some squares and rectangles. It's pretty cool. But this next example is going to kind of talk about you creating your own squares and rectangles with a given. Okay, so here's the instruction. It says, draw a rectangle with an area of 60 square units and a perimeter of 32 units. All right, so let's just say you had a pencil, because you can erase a pencil, right? And let's just draw a rectangle here. Well, there's my rectangle. I drew a rectangle. Let's actually see if it has what this says. Okay, does it have an area of 60? Well, the way a grid works is you count these as units. So this is 1 unit, 2 unit, 3 unit, 4 unit, 5 unit. So this is 5 units wide. Okay, this is 1, 2, 3 units long. Is 5 times 3 60? Nope. So that can't be my rectangle. So I need a rectangle that multiplies to 60. That's what I need. So here's what I'm going to do. I'm going to write the number 60. I'm going to ignore this perimeter part first. I don't need that right now. I need to figure out all my options for what multiplies to 60. So here are my options. I've got 2 times 30. I've got 5 times 12. I've got 6 times 10. There's some other options too, but we're going to work with these 3 to test, okay? So if I have these options of things that multiply to 60, then I could have a square that has a side length of 2 and a other side length of 30. Now the question we have to ask ourselves here is, what about my perimeter? I need whatever those 2 numbers are to also have a perimeter. So let's draw another rectangle, right? If I draw a rectangle here, 2, 3, this is 3, 1, 2, 3, 4, 5, 6, this is 7. So 7 times 3 is 21. But if I add these up, let's take a step back actually. I'm not going to like that example. Let's go back to this 2 times 30. If I have a square that has 2 and 30 here, the area is 60, right? But my perimeter is really 30 plus 2 plus 30 plus 2, which gives me 60 plus 4, which gives me 64. Is that what I want? Do I want a perimeter of 64? No. So this can't work. Okay. How about 5 and 12? Okay, so this would give me 64. Nope, not okay. We don't want it. Let's try 5 and 12. And again, do you see I'm drawing pictures to help me? So 5 times 12 does give me 60, but will my perimeter give me 32? Let's find out. This has to be 5. This has to be 5. 12 plus 12 plus 5 plus 5 gives me 24 plus 10 gives me 34. Oh man, I'm so close. 34 is super close, but is it 32? Nope. So that doesn't work. All right, erase. This is why we use pencil and try again. So I need now 6 and 10. So let's do 6 here and 10 here. That gives me 60 in my middle, my area. This side must be 6. This side must be 10. So now let's add it all up. So 10 plus 10 plus 6 plus 6 gives me 20 plus 12, which gives me 32. Hey, look at that. Yeah, I got my 32. So that means that this is the rectangle that I need to put on this grid. So it's 10 long and 6 wide. So I'm just going to count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then 6 down, 1, 2, 3, 4, 5, 6. Now I can draw my rectangle, label it with 10, label it with 6, and I will say, hooray, you did it. You found a rectangle that has an area of 60, but also a perimeter of 32. Okay, So it's a lot of testing. It's a lot of trial and error and figuring this out. You're trying to relate the two things together. Okay? Good luck. After your mastery for this learning target, you will be doing a little cool project that deals with this. I think it'll be fun. I think you'll like it, but expect that will be incoming. Okay? Good luck on your practice.